Make me a superhero. Who wants to fly to the pet store?
Hello everyone, this is Mr. Murray for another video on graphs of polynomials. So we're going to work on sketching a graph given a polynomial. Now, you could probably do this in your calculator, but we really have to get used to all of these words like end behavior, roots, y-intercepts, degrees, all of that, in case we're given a word problem that has all of those terms in them. So let's not cop out and just do the calculator method. This unit is all about taking it to the next level and really understanding what's going on. This is going to be a really short video, so just hang in there and do all the work. It'll really pay off later. Okay, so sketching x squared times x minus 2, but incorporating everything we know and everything we've learned about these terms right here. So if you look at this equation, what's the degree? 3. Because you have x squared, so that would be x times x, and then another x. If you multiplied this out, you would have x cubed. So the degree is 3, and the leading coefficient is positive. Let's fill that in. So what does the end behavior of an odd degree that's positive look like? Refer to your worksheet. It looks something like this. Right? Okay. So that's our end behavior. So I think in here I'll just do a little up arrow like that and a down arrow like that. What are our roots? Well, we have a double right here. That would be x equals 0. And another one, x equals 0. And x equals 2. So let me put them on my graph right now. Here's 0 and 2. Okay, this is the y-intercept. If we plug in 0 for x, we'll figure out where our graph should cross this y-axis. So let's figure that out. Okay. Factored form would look like this. X times x times x plus 2. If we plugged in 0 for that, we would have 0 times 0 times 2. That equals 0. So our y-intercept should be at 0. Okay, well that's one of our roots right here. That's where the y-intercept will be. So what you should remember is that a double root, like x squared, from your previous worksheets, I think I said something like bouncing ball, because it sort of intercepts the axis, but it doesn't go through it. It bounces off. That would be a double root, and that's how you can tell. Here's another one maybe heading the other way. That would be 2 roots right there. Okay, so let's see if we can sketch this out now. I know I have a bouncing ball at 0, and I know that my end behavior is supposed to look like this. So even without knowing what the actual end game is, I think I can just start like this. Put an arrow headed down in the 3rd quadrant. Put an arrow kind of bending up in the 1st quadrant. Now let's look at our intercepts, and what should we do? Well, if this is the first stop heading from left to right, I have to get to 0 and connect this line, and I have to bounce. I'm going to go to 0 and immediately turn around. That's my turning point. Now there's only one more root that I need to get to, and that's the number 2 right here. So how am I going to get to that and then exit the graph this way? Because we know we have to. That's our end behavior. Well, I'll just go down a little bit, turn around, and go right through my next root. And that's it. We just sketched the graph of this. Now, if you want to check your calculator to see how awful my picture was to what it should be, let's do that. So x squared times x minus 2. Let's bring that up and see what that should really look like. X squared, parentheses, sorry, x minus 2. I just forgot. X minus 2. Okay, zoom 6 will give you a nice 10 by 10 graph. Yeah, that's it. I mean, sort of. Hang on. There we go. Yeah, they look all right. Not so bad. I guess I could have been a little more rounded in this area, but that's certainly what the graph should look like. So yes, you could use your calculator, but I'm telling you that's a complete cop-out. We're beyond that at this point. This course is talking about these definitions right here. So just use the calculator to verify your results, but be very familiar with what all of this means and how it affects the graph, and you'll be just fine. Okay, let's check the next example.
Water gun. Water gun.
Hey, what's up, man? It was a good shirt.
So what are you doing tonight?
Burrito.
What?
This looks crazy. What's the degree? 1, 2, 3. Okay, third degree. It's odd. And the leading coefficient is negative. Let's go look at your notes and ask yourself, what would a negative coefficient of a third degree function look like? Well, that's this way. So let's put that here. Perfect. Okay, what are my roots? The roots are going to be the opposite signs, right? If you were to imagine that this was a t-chart and we set this equal to 0, you would have -1, +2, and -3. Sorry, +3. So my roots are at x equals -1, x equals +2, and x equals +3. Let's go ahead and plot those roots. Here's -1, +2, +3. Very close together, so this drawing is going to be a little bit interesting. Where should I cross the x-axis? You know, I'm going to be going like this due to my end behavior. I'm going to kind of, I don't know, maybe do something like that. Where do I cross? That's the question I'm asking. So that's what this is going to find out. Let's plug in 0 for x. That'll give us the y-intercept. And I'll know exactly where on this line my graph should be going through. So let's not forget about the negative. Very important. F of 0 will be negative of 0 plus 1, 0 minus 2, and 0 minus 3. Okay, so that gives us -1 times -2 times -3, which equals -6. So right down here is where my y-intercept will be. And I'm going to have to pass through these roots right here. Okay, so looking back at our end behavior, which looks like this, let's connect these arrows. Moving from left to right, I know my first stop is -1, and I have to make a turnaround at -6. So here we go. This is not going to look pretty, but it's just sketching, and that's okay. So I pass through my first root. I'm heading down. I have to cross through the y-axis. So there I go. But now my next stop is this 2 up here. Well, it's not a double root, so I'm not going to turn around. I'm going to go right through it. So I'm going to come up like this. But now what? I know the end game is this right here. This is end behavior. I have one more route to pass through, and that's number 3, and then I have to leave. It's time to go. So somewhere over here, and that's not exactly super important for this question, for this level that we're at right now, you just have to turn around. And let's pass through that last route and connect the arrow. Kind of looks like Harry Potter's scar, right? Okay, so that's my sketch. If someone told me what the local maximum was and they gave me an actual value, then my graph would be much more perfect. But they didn't. So if you're not given a local max or a local min and you're asked to sketch, well, then it's your freedom as an artist to do whatever you want, as long as you pass through these very important points and you understand the end behavior. Then you'll be fine. Let's go to the calculator and see what this looks like. You should be doing this with me. Okay, zoom 6. Not bad. Check it out. There we go. Yeah, sort of looks like it. You know, I mean, I put these in first, right? So they were a little out that way. It looks like on the calculator it does this. But you're not going to get points off for that. The idea was, can you sketch this graph given the information you have? And you certainly could. This looks just like that. I have a period 3, I believe it's period 3, from Gills, some Fetty Wap, which is totally cleaned up and ready to go. So enjoy the music. If not, hit mute. We will do the next 2 examples together, and let's take a look at the end to make sure we're on the same page. Enjoy.
Baby, won't you come my way? Got something I want to say. Can I keep you on my way? But first off, I'ma start by saying this. All hands shots, if you can take my and I'm too turned when I shoot, swear I won't miss. Baby, won't you come my way? Baby, won't you come my way? Baby, this is something you should know. I don't ever chase no hoes. Spotted you had that girl. Watch me pull out all this dough. Take you where you want to go. Flexing on your ex, I know. He ain't never take you out. Barely even left your house. How dare that nigga run his mouth when his pocket's in a drought? The last single he put out didn't even make it out. And he dumb as hell, and I swear his don't blink. And he disrespect 2 shots and I won't blink. Never really care what the these think. I got deep pockets, I swear my so sink. And he mad as fuck, big Sue up all she sing. And he mad as Sue up in her dreams. He mad as when they sex, she scream for me. Big Sue up, but these should be. Baby, won't you come my way? Got something I want to say. Can I keep you on my way? But first off, I'ma start by saying this. All hands shots, if you think you can take my and I'm too drunk when I shoot, swear I won't miss. Baby, won't you come my way? Baby, won't you come my way?
Baby girl, you can stay the night to the morn. All this ice on my arm. What you like, what you want, and I might put you on. Smile, can't you see? And I rock 17, all these knots in takes you to the head. 'Cause baby, you the baddest. Baby, you the baddest. All this money, I'ma cash it. And I'm swerving all the traffic. While I'm trapping out the mansion. And I'm moving through the tri-state. You 200 on the highway. And I'm swerving in my eye. Baby, you should come my way. Squad.
Okay, that was perfect timing. So take a look at this graph. It's like a W. There's an even degree. The leading coefficient is positive, so your end behavior should look like this, and that's why it looks like a W. You know, because the tails of this function are heading up north to infinity. And that's what your graph should look like. And on the next one, we had a little, wait, sorry. I'm sorry about that. I wanted to point out this first. The bouncing ball, you know, this x plus 2 squared, that's what that looks like. This is a root, but the graph does not pass through it because it is a double root. So it starts to head back up and then turns around so that it can come back through the origin, because that's another root, and the y-intercept, coincidentally, heads down south. It has to turn around to get back up through this last root and exit according to what we know the end behavior should be. Okay, the last example was pretty simple. It was a parabola. You know, if you distributed this, you'd get an x squared, negative x squared, plus 4x. And that's a second degree equation, which is even. The leading coefficient was negative. Therefore, that's our end behavior. The roots are 0 and 4. So I plotted them there. The y-intercept was also 0. So if this is my end behavior, and I move from left to right, and I have to pass through this root first, well, this is the only way my graph can look. And again, I don't know how high that local max is going to be, but maybe if they gave us some information, we could narrow that down. Okay. I hope that video was easy to understand. Again, always available for extra help. Take care.